Hey folks, Jeremy Simon here from 3D Universe. Thought it was time for another Ultimaker Cura tutorial. These guys keep adding nice new features into the software, and sometimes I just happen to stumble across them, and there were a few that I thought would be worth sharing, especially for the more advanced users out there. If you're really looking to get control over how your objects are printing, there's quite a few things available to you in Cura that you may or may not be aware of, so I'm going to try to touch on a few of those here. I have here just a test object that I created real quick in Fusion, just so I could show some of these features. Just got different types of geometry here with some different sorts of overhangs, some flat surfaces, curved surfaces, some bridging, some extruded text, just, stuff that'll show how some of these different settings can be used. So let's start with just some defaults. I've got this set up here with for an Ultimaker S5 using 0.4 millimeter print cores, just using tough PLA. And I'm going to start with just basic settings. So we'll slice just using the recommended mode, 0.2 millimeter layers, 20% infill. Don't need bed adhesion options here. Let's go ahead and just slice with defaults. And we get an estimated print time of 13 hours, 39 minutes. Using 186 grams of material at a cost of about $12.38. Now, those of you who have used Ultimaker printers already know that they err on the side of quality as opposed to speed with their settings by default. So there's a lot you can do to optimize things and get things to print more quickly without losing a whole lot on the quality side. And we're going to look at some of that here. Now, let's say in this case we're more interested in speed than quality. There's always a sort of a trade-off between the two, and there's no one right answer in terms of how to slice any given object. It's always a matter of sort of finding the settings that most closely match what you're looking for, and it's going to be a sort of somewhere on that spectrum between the maximum speed and the maximum quality, depending on which of those is more important to you for a given print. So in this case, let's say that we're more interested in speed than quality. And so the first thing that I would do is go to a larger nozzle. A larger nozzle is going to let you print things more quickly using thicker layers and wider lines, but it comes at the expense of quality, of being able to do finer details in your prints. So it depends on the specifics of your object. Let's go ahead and slice this to give an example. So this is using a 0.4 millimeter nozzle. And if we go to the preview mode here, and we set our color scheme to material color, we'll see that everything looks nice, prints nicely, including that extruded text on top there. No problems at all. And that is where you'll see a difference. If I change now to a 0.8 millimeter nozzle and reslice and go to preview mode, you'll see that that top extruded text really kind of falls apart. It just is too thin for the nozzle to be able to extrude those lines because the lines of the text are thinner than the 0.8 millimeter nozzle that we're using. Now you could adjust your line width to try to get it to print those sorts of details, but that's not the ideal approach. Down here you can see that it is printing this text okay because that's a larger, a thicker text, and it was able to handle that, but that text on top did not come through. So just be aware of that trade-off, that you will lose some of the very fine details where it comes to things sort of sticking up out of your object that need to be extruded by the width of the nozzle. If you increase your nozzle size, you do two things. Number one, you increase the line width, which is going to speed up each individual layer, and you can also increase the layer thickness, which is going to reduce the number of layers that need to be printed. As a general rule, your layer thickness can be up to about 75% of your nozzle diameter. That's not a hard and fast rule. You can go thicker even by increasing your temperature to get a better flow rate, things like that. But as a general rule, let's say 75% of nozzle diameter. So with a 0.4 millimeter nozzle, our layers can be up to about 0.3 millimeters thick. If I change that to a 0.8 millimeter nozzle, now our layers can be up to 0.6 millimeters thick, and we have half as many layers. We also have wider lines, so that means each layer can be done more quickly. So let's go ahead and do that. Let's change it to a 0.8 millimeter nozzle, and let's start to customize some of our other settings here. But before I do that, I'll just reslice, changing nothing but the nozzle size. And already we see that our estimated print time is down to 7 hours, 56 minutes. So it's a significant time savings already. But Let's go further. I'm going to go into the custom mode now. This is where most of you will be working if you're more advanced with settings. This is where you can really get full control. Now, by the way, I should mention I've got all settings being shown here. If you're not seeing this, right up here, this little hamburger icon here lets you select what you're seeing in settings visibility. Basic is just going to show the basic settings. Advanced shows more. Expert shows even more. And all, which I'm looking at here, shows everything. If you want, you can go into Manage Setting Visibility, and that's where you can really fine-tune which settings are showing, and you can show or hide each individual setting to your liking. For right now, I've got all of them turned on. First thing I'll do is change the layer height. Let's go up to a thicker layer. I'm going to go to 0.35 here. And there's a reason that I'm going to that. I could go even a little thicker. Like I said, I could go up to 0.6, but I'm setting it at a kind of a midpoint because of a feature I'm going to show you shortly here called adaptive layers. And I'll explain that shortly, but for right now, I'll set the layer height at 0.35. And let's just slice again to see what that does using all layer height of 0.35 throughout. And you can see that already reduced our time further down to 4 hours, 59 minutes. Now let's keep going down here. In the speed section, Ultimaker is very conservative when it comes to speeds. Now printing at 45 millimeters per second is a good idea when you're looking for good dimensional tolerances and you want things to have really nice surface quality, but you can print a lot faster if quality and dimensional accuracy is not the top priority. And again, since we're focused more on speed here, let's just go ahead and be aggressive here. I'm going to go up to 80 millimeters per second. But we're not going to be using that speed throughout the entire print. We're going to do some things here that will pull that speed back in certain conditions. Some of that's built right here in the speed section. So for example, it'll slow down a bit for the walls, and it's going to go a lot slower for the initial layers. But there's more that we can do. So if we scroll way down to this last section here, which is experimental, there's a few things I want to show you here. Number one is use adaptive layers. This is a really powerful setting that I showed in a previous video, but they've made some significant improvements in how this works since then, so it's worth revisiting. Now, when you enable adaptive layers, 3 subsettings become visible, and it's important to understand each one. So if you hover over each setting, you'll get the help text over there on the left, and you'll want to study each one of these. Let's go through them now. Adaptive layers maximum variation means how much you can vary the layer height either up or down from your base layer height. So if you recall, we set our base layer height to 0.35 millimeters. So what I'm going to do is I'm going to set this value to 0.25, and what that means is the layer height will be allowed to vary up to 0.6 millimeters and down to 0.1 millimeters because it can go 0.25 millimeters in either direction from what I have set as the base layer height. The next setting is adaptive layers variation step size. So from each layer to the next, this specifies how much the layer height can change. Now, currently it's set to 0.01, which means it's only going to change each layer by 0.01 millimeters. I want to let it change a little bit more quickly than that, so I'm going to go to 0.05 here. That means it can go from a 0.25 millimeters on one layer, it can go to 0.3 millimeters on the next, and then 0.35 millimeters on the one after that, and so on. The third setting here is adaptive layers topography size. What this means is how much distance is there from the edge of one layer to the edge of the next layer. So think about a slanting surface where the layers become more visible. How close do you want the edges of each layer to be? That's going to determine how thin the layers need to get in order to achieve that setting. So by having it set at 0.2 millimeters, that means that the very edge of one layer, like if we looked at these slanted surfaces here, the very edge of one of these layers can be 0.2 millimeters away from the edge of the next layer. So I'm going to leave it at that for now, and we'll move on. So those are the 3 settings for adaptive layers. Okay, so another setting that we have here is overhanging wall angle and speed. What this is useful for is slowing down the print speed on areas where there are overhangs. Like if you look at these slanted surfaces here, you're going to get a cleaner surface if you go a little bit slower on those overhanging walls. And so what we can do is specify an angle and a speed reduction for that. So there's 2 settings here. The first one is the overhanging wall angle. And what this means is any walls that are overhanging more than this angle are going to be treated as overhanging walls. The default is 90 degrees. Now, it's impossible to overhang more than 90 degrees. So what that basically is doing is disabling this setting. Okay, if you have a 90-degree overhang, that means you have a horizontal surface and you can't get any more than that. So if I reduce this to, say, 20 degrees, that now means that any wall that's overhanging more than 20 degrees, which would include all of these slanted surfaces here, those are going to be treated as overhanging walls. And this next setting will then apply. So let's say that we want to reduce those by half, so we'll make this setting 50%. Now that means that any of these overhangs that are more than 20-degree overhangs are going to be printed at half of the speed of the rest of the print. Now, another setting that we have here that's very useful is bridge settings, but I'm going to come back and look at that one later because I want to show you the difference. I want to slice it without that first, and then we'll turn it on. Moving on down here, another one that you'll want to be aware of is this small feature set of settings here. So small hole max size is basically the size of a feature that's considered small. So anything less than this size is going to be considered a small feature. So let's say small holes of less than, I'm going to go 15 millimeters here, so that anything that's even remotely small is going to result in these settings down here being applied, which is again a reduction in speed. Small feature speed, 50%. Small feature initial layer speed, also 50%. I'm just going to leave those the way they are, and we can see what that does here. I'm going to go ahead and slice with these settings and see what we have here. And I'm going to go back into our preview mode here so that we can see what's going on. Right now, I'm using the speed color scheme, which is very helpful for seeing how our speed is changing throughout the print. And what you're seeing is a couple of things. Let's scroll down through our layers here, all the way down to layer 1. Starting at layer 1, we've got this bright green color, which looks like it's a rather slow speed. Okay, well that's, if we scroll up to our speed settings here, that's because our initial layer speed is 20 millimeters per second. That's to be expected. As we keep going there, we've got this orange color, which is our maximum print speed of 80 millimeters per second. But then if we scroll up further, we see some different speeds. Number one, the lettering. Okay, why is that lettering going slower? Well, because of that small feature setting that we used way down under experimental. If we turn off that feature setting there, we go back to 0 for the small feature size and we reslice, you're going to see that that extruded text is back to orange. So it's trying to print that at the maximum speed. And it's probably going to look a little bit sloppy as a result. So that's what that small feature setting is doing. I'm going to put it back to 15 millimeter max hole size. And then those settings should be reapplied. If I slice now again, you'll see that that text is now in a green, which means that it's printing at half speed, about 40 millimeters per second. Scrolling up through some of these other layers, you're going to see that the same thing is being done with our walls here, the slanted walls, and that's because of these overhang settings we had here. Those walls are more than a 20-degree overhang, and therefore they're being considered overhanging walls, and they're being printed at 50% speed. But that only affects the walls, so the interior is still being printed at 80 millimeters per second. Now, keep going. You're going to see that similarly, the curved surface down here at the bottom had those overhang settings applied. There's a little bit of an outward overhang there, so that got slowed down. And then way at the tippy top of the print, the last couple of layers got slowed down just because of the minimum layer time setting. It's trying to not print those layers too quickly. It needs to give the material time to cool, so it's slowed down for that. Now, let's change to layer thickness in our color scheme view here. And now we see something interesting. We see that the layer thickness is changing throughout the print. And that's because of our adaptive layer settings. So what we see is down here at the bottom, where it's pretty flat walls, there's nothing fancy happening, it's doing the thickest layers possible. The yellow there is 0.6 millimeters. So we're getting the best speed that we can because you're not going to see those layers much anyway because they're being stacked right on top of each other neatly. But then when we get into this area where you have the slanted overhangs, it pulls way back on the layer height, goes all the way down to 0.1 millimeters, so it's using the thinnest layers possible, and that's because of this overhang over here where it's really got a steep outward overhang, and it wants to give us the smallest sort of step size possible, and so it's using 0.1 millimeter layers. Then once it gets past that steep outward overhang, this part in here, it's still got overhangs, but they're not as steep, so it's going with this middle kind of 0.4 or so millimeter layer height. And then as you can see past that in the yellow, it goes back to thicker layers because there's no more overhangs. And so it's adjusting this throughout the print as needed. When it gets into the spherical part, the middle section here, it's using real thick layers because there's not much curvature there. And then as soon as that curvature starts to increase, you can see that it gradually reduces the layer thickness, getting thinner and thinner and thinner, so that you get the best quality possible where you need it, and thicker layers where you don't need that, where it's not going to be visible. So this really gives us a nice trade-off, and you can see that our print time now is down to 3 hours, 26 minutes. So you're getting a really nice balance between speed and quality in this case. And if you wanted to skew it more towards quality or more towards speed, you can do that by adjusting these settings. So you might adjust your adaptive layers settings here so that you skew it more towards thicker layers. You might adjust your base speed, go even higher than 80 for your base speed, and then pull it back from there where needed. There's a lot of things that you can do to sort of fine-tune things here, but those are the basics of how you can get control over your layer thickness and your print speeds using some of the settings that are available here. All right, so now that we've gotten a pretty good print time on this print, there's something else I want to show you, and that is bridging. So if we look at this bridge that's being printed down here in the preview mode, we see something interesting. Look at how that bridge is being printed. Look at the direction of those layers. We can see it more easily if I scroll down to those. I'm going to go back to a top view here, pan around a bit, and now let's scroll down to exactly that layer. Let's see, now that's layer 60, yep, layer 60 there. And then we can actually use this horizontal scroll bar to animate that layer. So look what's happening. It's going to try to draw the outer walls, which is going to be okay. It can bridge that gap. Okay, you're going to have those two strands there. But now it's going to try to print across those strands at this angle, and that is just not going to work very well. It's trying to sort of connect up at each end there, going back and forth, and you're going to end up with a very messy bottom surface doing it that way. If, however, under this experimental settings section, we enable the bridge detection, enable bridge settings here, I'm not going to mess with any of the settings down here because I found that the defaults work pretty well. You can tailor all these settings if you like, but I'm going to leave them on defaults. Just by doing that one thing, enabling bridge settings and reslicing, look what happened. That exact same layer is now being printed the way we want it to be printed, going back and forth, connecting up at either end. We're going to get a nice clean bridge that way, and then building up from there, it's going to start going across and then alternating directions. And that's exactly what we want to see. You're going to get a much cleaner lower surface on that bridge. I'll go back up to layer 60 here. There we go. So that's going to give us a much nicer result on a bridge. So if you have areas of your print that you know are best handled with bridging, enable that here under experimental settings and you'll get a much nicer result. Okay, so now we've got a pretty good set of settings here. We've got our print time down to just under 3.5 hours, but let's say I want to customize things further. Maybe there's certain things that I want to do in parts of my object that are different than other parts of the object, and you can't do that using the global settings over here so well. Well, you've got two other very powerful tool sets at your disposal in Cura, and I'll show you those here. Number one is something that's based off of the support blocker tool. So let me go back to preview mode here, and you have to select your object first. Notice that you don't get these tools until you have an object selected. So select our object. Now I go over here in the toolbar, and I'm going to select this support blocker here. Now, usually this is used for blocking supports, just as the name suggests. So if I drop this in here just by clicking somewhere in my object, that just drops a little cube there, which I then have to manipulate by first deselecting my object. Because right now you might notice that both my object and the support blocker are selected. So let's just click out here to deselect everything. And now if I click back on that support blocker just to select it, I can now manipulate that object just like anything else. So let's scale it, make it bigger so I can actually do something with it. Maybe we'll rotate it a bit so that it's oriented like this part of the object. We can move it around. Let's put it so that it's just kind of overlapping this end here. And so by default, this object would do just as the name suggests. It would block supports. So if I enabled supports for this print here, we'll do that now just so you can see. We'll go ahead and turn on supports. And we'll slice. And if we go to preview mode, you'll see that we now have supports under there, but we don't have supports under here because of the support blocker. Okay, so that's how the support blocker works. But we can also use that support blocker in different ways. So I'm going to turn off supports, so we don't need them for this print. And now we can go back to that support blocker object. And over here on the toolbar, the next one up is called Per Model Settings. And if you click on that, you'll see that it's defaulting to Don't Support Overlaps, which is what gives it that support blocking function. But you can change that to say Modify Settings for Overlaps, Print as Support, or Normal Model. So normal model would just mean that you're going to print it as a model. It's going to print solid. We don't want that. Print as support means that that whole area will get printed in as support, which also is not very useful in my mind. But this one here is quite useful. This one that says modify settings for overlaps. That lets you modify that region of your printed object that overlaps with this. And you can only modify certain settings this way, but there are quite a few. So you can modify the infill mesh only, which is only going to modify the interior of your object. Or you can choose cutting mesh, which is going to modify everything that is overlapped, including the walls and the interior. So choose one of those options, and then you can select your settings. Now, not all of the settings are available here, but quite a few are. So for example, you can change your, let's see, infill. Maybe I want to have more infill. Sometimes it's hard to find. You can just type up here, infill density. Maybe I want to change the infill pattern too. Maybe I want to change the speed for the walls. A lot of different settings you can change. So choose the ones that you want. And let's say over here, infill density, instead of 20%, I want 50% infill for this region. And let's change it from cubic to, oh, I don't know, we'll do zigzag infill pattern. And let's say we want the walls to go really slow here, all the way down to 10 millimeters per second. And now if I slice and preview, what you're going to see when we scroll down through those parts of the layers, let's change our color scheme to speeds. So you can immediately see that that whole section over there, the walls, are being printed much more slowly. If I scroll down a little bit more, you'll see that. So the interior is still being printed at the full 80 millimeters per second, but those walls are cut way back based upon the settings that we specified for that custom region. The other thing that you can see is the infill density. Notice that that is a much denser infill. That's a 50% infill compared to 20% everywhere else. So it is modifying those settings that we specified only for that area, and that is a very powerful way of customizing different parts of your prints. Another option that you have is something that you'll find under the Extensions menu, Post-Processing, Modify G-Code. And what you can do here is add a script, and there are a number of options here, several of which are quite useful, but I'm only going to show you this one here, Change at Z. And what this does is it allows you to change certain settings at specific heights of your print. So you simply specify a height, let's say 10 millimeters, and you can change these settings at that height. Now there's a much more limited set of settings available in this tool, but you might find that there are some things you can do here that you cannot do using the support blocker customization approach that I showed before. For example, changing retraction settings at a certain height. Maybe you want to change the amount of retraction or the speed of retraction. That's something that you actually don't have the option to do using that other method. So there are some things that you can do in this tool that you cannot do there. And so these are the two methods that you can look to control settings within different regions of a print differently from one another. All right, that's going to do it for this tutorial. I hope you found it useful. As always, please post your comments below. If you have any tips or tricks of your own, please share them. And you're always welcome to reach out to us at info@3duniverse.org if you have any questions. Thanks. See you next time.